So we are looking at financial mathematics, and within this we have two topics, MSF4 and MSF5. The MSF5 topic focuses on annuities, but today we are looking at MSF4, which is investments and loans. So if we have a look at our first slide, we will be looking at the future value. And the future value formula can also be known as the compound interest formula. So I'm going to write that up there so people don't forget. So if you ever see compound interest formula, that is the same as the future value one. And this formula, the first one here, is by far the most common one. So you can get, there's three different types as you can see here. They're just written differently, but all are the same thing. And this one here is by far the most common. It will be the one that you see on your reference sheet. And it essentially is the future value is what we are going to get. It is going to be the present value but plus interest, and so that will be the future value. Our rate is known by the R, and the number of periods is known by the N. So if we have a look, we'll do an example now using this formula. So Blake invests $7,000 over 5 years at a compound interest rate of 4.5% per annum. Calculate the future value after 5 years, answer correct to the nearest cent. So I'm going to do question A down here. And we know that the future value equals the present value 1 plus R to the power of N. And so I'm going to fill in what we know by subbing the question into our formula. So we have to calculate the future value. So we don't know that yet. So I'm going to write future value there. Our present value is what he invests. So it's going to be the biggest number, the $7,000. So if he invests $7,000, 1 plus the rate, and we know that the interest rate was 4.5% per annum after 5 years. So then 5 years goes in the N location. So then we know that our future value, once you put this into your calculator, it will come out with the future value. So it will come out with 8,723.27, and that is to the nearest cent. Something to keep in mind is that the rate here can be written as 4.5%, or you can do it as a fraction with 0.045 or 4.5 divided by 100. So that would be the future value. Once you invest $7,000 over 5 years at a 4.5% interest rate, your new value will come to a total of 8,723. So the future value, if you're compounding, will always be greater than the present value. Now let's have a look at question B. Calculate the present value of an investment that has a future value of $500,000 over 8 years with an interest rate of 8.5% per annum compounded monthly. So this question is going to be a little bit harder. Firstly, once again, you'd write out your formula because that is what you know. So for B, our formula is our future value equals the present value 1 plus R to the power of N. And now we're going to fill in what we know. So this investment has a future value of 500,000. So we'll put that in the future value equals, we have to calculate the present value. So we're not sure what the present value is yet because we have to calculate it. 1 plus, what is our rate? Our rate is 8.5% per annum compounded monthly. And when something's compounded monthly, you have to times the years by however many months there are in a year, and you have to divide the rate by however many months there are in a year. Now I'll explain why we do this. If something is invested over years, over 8 years, but it's compounded monthly, that means each month for 8 years, it will be compounded. So it won't be compounded 8 times. It will be compounded 8 times 12. It will be compounded each month for 8 years. So that's how we get the 8 times 12. And if we know our interest rate is 8.5% per annum, and if per annum just means per year, but we're compounding monthly, we have to divide the rate by however many months there are, because that will give us our monthly rate instead of our yearly rate. So that's why we times, and that's why we divide. And when you do that, when you put it in your calculator, 8 times 12 will equal 96. And 8.5% can be written as 0.085 divided by 12. So when we do our rate, we know that we have to put in 0.085 divided by 12. So that's the trick. This question, that's why it's harder, because you have to know to divide the rate by 12 and times the number of periods by 12. So once we get that, we can't just put it into our calculator like we did for question A, because our thing we are trying to find is on the other side of the equal sign. It's on this side. If it was where the 500,000 was, we could easily put it into our calculator. But because it's on our other side, we have to do some changing the subject of the formula, because we want to get PV by itself. So to get PV by itself, we can simply take this whole thing and divide it by 500,000. Because if we know PV is times the brackets, we want to undo the times, and you undo the times by dividing. So then we would get 500,000 over here divided by 1 plus 0.085 over 12 to the power of 96. This number here, our present value, is going to be smaller. So when you put this into the calculator, you will get an answer of 253,916.41. And that is our present value. So the present value shows that if you invest this number, the number we just found, if you invest this for 8 years with an interest rate of 8.5% per annum compounding monthly, you will get a future value of this month. All right, let's have a look at our next slide. So now we're just calculating the compound interest. Now the interest is simply the difference between FV and PV. So if I have a future value of $8,000 and I had a present value of $4,000, the interest would be the difference between the two, which would be $4,000. This means that when I invested my $4,000, it gained another $4,000, and the difference between the two is interest, and that's how much it increased by. So let's have a look at some examples. So Tyson invests $10,000 over 10 years at a compound interest rate of 7.5% per annum. Calculate A, the amount of the investment after 10 years, correct to the nearest cent. So A, first thing we do is we write down our formula. which is future value equals present value times 1 plus the rate to the power of n. Now we need to fill in what we know. So the amount of the investment, that will be the future value. So we don't know that. We have to calculate that. And we know that he invests $10,000. So that will be our present value. That's how much he has at the present time to invest. 1 plus our rate is 7.5% per annum in years, and this investment is in 10 years, so we don't have to change anything. 7.5% for 10 years. And when you calculate that, put it into your calculators, you will get a total of $20,610.32. Now I'll do question B on this side. Now we have been asked to calculate the interest earned after 10 years, correct the nearest cent. So if we know that the interest, I, just equals the future value minus the present value, we can just go ahead and get 20,610.32 minus our present value, 10,000. And this is going to give us the interest, which equals 10,610.21. So 10,610.21 is the difference between the future value and the present value, or how much has been earned on the present value to give us the future value.